Zaretti. I'm the course lecturer.
I'm Hadi Merkuya. I was involved in this course to upload some of the contents and
help build it.
Yeah.
And I'm Dave, one of the course TAs. I hang around on the forums and try to give helpful answers to questions if students don't jump in immediately and do it for me.
So
usually they do.
Yes.
It's brilliant.
So welcome to our second Hangout. This is officially week 4 now. Our last Hangout was on week 2. Since then, you've learned lots of new things. You've learned about remixing games, and we saw how we could remix a simple Pong game. And then on week 4, we had a look at procedures and cloning. So there were lots of different animations and games there. I remember the one with the fireworks. I really liked that, and there were lots more. So yes, let's before we start talking about your questions and the points that you raised in the forums, I think we would all like to say that you've been doing a great job.
Yeah, well done.
Definitely.
Awesome so work. Just like Dave said, we really need to step in your discussions in the forum because you're brilliant. You're just helping each other, and you ask really good questions and give also very good answers, right?
Yeah, and some of them, like, we need to search as well to find answers for them. So that's really good. So because we're learning as well by looking at your interactions, I think.
So well done, everyone. Let's start with having a look at a few of your questions from the Hangout forum. So I'm going to start. The first question is from Anders, and he's asking, is there a simple way to display text without a sprite saying it or thinking it? And there were lots of suggestions after you posted your question. I'd say, so first of all, the easiest way to have some text be displayed is, I think, just by having a sprite, a character, saying it. What you could do, for instance, when giving instructions for a game, is to create a separate backdrop where you show, say, those instructions or any text that you want to display, and show that at the very beginning of the game for a few seconds. But be careful, because all your other characters, anything else you program, needs to wait for that time as well, right? So just to keep it in mind. Do you guys have any other suggestions?
Well, I just thought about a way, but I'm not sure I haven't tested it. Yes. But I wonder if you can also make a character that is almost invisible, like a dot or something. And then from that dot, you open up, because that could be just a character with 1 pixel, and then you can say this, but there is no character. So it might be a way of hacking it.
Alternatively, you could conceivably make a character that is in fact a screen capture of some text.
Good. So some suggestions for you to try out. Very good. Right. Let's move to the second question, which is from Lisa, if I'm pronouncing your name right. And the post subject is things I'd like to be able to do, but don't know how. Good. So one of the things that Lisa, would like to do is to, for instance, make a sprite move and talk at the same time. This is a very good question. And actually, we're going to be looking at topics around this question next week. So to give you a quick answer, there's something in Scratch called message broadcasting. And this helps us kind of coordinate our sprites, or coordinate different behaviors of a specific character. So that's definitely one way to do it. If you want your sprite to be moving and talking at the same time when the program starts execution, you could just have that by having 2 separate when green flag clicked blocks. And that should work as well. That, again, we will see next week. And when we talk about concurrency, which is about things happening at the same time. So excellent question. And I know that one of the replies that you got from Nova was just about that, message broadcasting. So well done.
So I think that would be useful as well. Like when you want to have, I don't know, like in the helicopter game, if you want to move in both direction, up and forward, or so then you can introduce those like a forever loop for each individual key, and then they all can happen at the same time.
Yes, yeah, very good. And I think that's a really good question, because you do want things to be happening at the same time. That's, it's a basic thing for you to include in your programs. So good question, good helping, and we'll see more detail about this next week, in a few days actually. And the last question that I'm going to be talking about just now is from one of our students asking, how can I post an SB2 file on my own webpage or share it on Facebook? And right after you asked your question, then one of your fellow students came in and said, well, there's this, there are embedding options in Scratch when you're logged in. So have a look at that. And I suggest you come back to us in the forum saying whether it worked and what you found difficult or easy, any tips for the rest of the community. So we know how to go about it.
I actually haven't done this before myself, and when I saw the question, I went and looked on the Scratch Wiki website. There is a section called How to Embed a Project, and then they suggested 3 ways that you can do it. Like there's one way of hacking it, and there are their own way that you go and click on share. But I think, as you said, it'll be great if someone actually do it and share it with everybody. How to do this process, step by step, basically.
So we're looking forward to hearing from you.
So I'm not going to do it until we get the instruction from you.
Yeah, and that's me for now. So perhaps it's worth talking about what was happening in the forums during week 3 and week 4.
Yeah.
So, yeah.
Do you want to?
Your week 3.
So first of all, a few things I really liked and enjoyed. But before I get into that, I was looking at something today myself. In Scratch, you do a lot of remixing. So it's really nice looking at remixing branches. And then in real life, that's real life as well, but in kind of bigger project, for example, an operating system of Linux, which is Windows or Mac. If you search on Google or DuckDuckGo, search for Linux kernel video visualization, then you'll see how it's been developed over 3 or 4 years, a project, and different people branching it. So it's quite a nice thing to see that the things you're actually doing is what we're doing and other people are doing as well, just different platform.
This sounds a little bit like the remixing tree that we can see in Scratch, right? So you
it's
visualize
exactly
it.
The same.
Cool.
Yeah, but I think it's quite interesting to see that a project, how it's kind of forms and changes.
And the community builds
exactly.
The project.
So Linux actually community is one of the biggest open source development project in the world. So you see how people are coming. Some people will come and make a change for I don't know, a week or something, and then they disappear. And then some are just there all the time.
Cool.
I played a football game and a pizza game. I think they're both developed by Slava and also Kate and her team. They added some new graphics for the game. They're all looking great. I looked at, I think it's Bavna, sorry if I'm not pronouncing it correctly. It was a dragon animation game, which looked really good, but I think, as you mentioned yourself as well, it'd be good if you work a little bit more on the dynamics of it. It's a really nice game, but for example, I was going to mention, I saw another game by Andre called Help Hoppy Home. And I think that was a really great example of design, because when you, in game development, I did my master's in game development, and there they were telling us a lot about how much research goes into basically the dynamics and how you slowly increase the difficulty of the game.
So what do you mean by dynamics?
Well, dynamics are basically, when you think about a game, you have a level design, which is in Scratch language, which will be the backdrop and changing of backdrop, clouds coming. And then you have dynamics for example, in the level 1, I'll use the example of Help Hoppy Home. In level 1, I'll move the helicopter from among the clouds, and I get into from point A to point B, and then I finish that level. And then in level 2, there are more dynamics happening. So there is the clouds, and there's a dragon coming and following me. So there's always that thinking of how to keep the energy of the person who's playing up and excited, and also curious of what am I going to explore in the next level, and also slowly introducing like some prizes, like you can also gain things, or you can see feedback. So that's kind of like how you think about dynamics.
Yeah. So I suppose one idea is about having different lives, and I don't know, gathering, maybe you have a score, maybe you have, I don't know, some extra tools or things that you gather and you can use.
Exactly. Or you can, for example, in the help the hobby, there are 3 of those elements. I actually didn't manage to finish the level 3, but I only tried for a few minutes. But you can think about, you can have different clouds. You can have a cloud that is a dark cloud that makes your character smaller, and you can have a blue cloud that makes your character bigger, and you need to choose these 2. And you can introduce these different puzzles, like, and difficulties in different levels.
I mean, I should say that, I mean, these sorts of dynamics, I mean, this is something that's common to not just games, but storytelling in general. I mean, if you're writing particularly a longer form story, writing a novel or something like that, you have to keep raising the stakes as you go to, start off with a character with a problem, and they work towards solving that, and then along comes a bigger problem, and so on. And at the end of a chapter, all of a sudden, huge, big, terrible problem shows up, and then you want to read the next chapter.
Yeah.
And I mean, just as with a game, you have to keep in mind what is the reader, or what is the player going to be thinking? What is their mental model of the story or the game so far going to be, and how can I keep on building on that to keep it compelling and interesting?
It's, as you said, it's in everything. I think one practice that you can start doing from now on, because you're all been involved in making games and interactions, just try and also analyze other medias around you. Like I started watching House of Cards, and then I always think, like, at the end of this episode, what happens to me that I end up watching them until after midnight, or so think about how you can create that, how you can make that curiosity, excitement. When do you increase in individuals to feel more energetic, and then when you kind of like slow it down a little bit. So and that's why, like, game companies, they employ people as game testers to do the debugging, as you were mentioning in the past weeks, and also to learn about the gaming experience. So you can feedback, you can say, I think the first level was kind of like complicated, or I didn't get the dynamics. Also try and make games that you don't put any instructions. Try and make your game that by going through your levels, I learned the dynamics. So in the first level, keep using the helicopter again, but in the first level, make the helicopter to go automatically, just hover, and then you do a little thing, and then on the next level, introduce gravity, so then you need to do 2 buttons. So kind of like make it step by step.
Yeah. Very, very good tips from you guys. Thanks. When it comes to testing the player experience, I'm sure, I mean, we can't really hire people to, we're not companies to hire people to do the testing for us, but we've got friends, right? You've got family members, friends that might be eager to just give it a shot and give you some feedback. In that case, my suggestion is, when you ask people that you know and people that you trust, push them to give them their honest feedback, because very often people like to be nice and they don't always say 100% what they think.
And I also noticed some people were asking, like, what teachers can teach in like using Scratch or in classes. So I thought I can talk to you very briefly about one of the projects that I'm working on. At the moment, I'm working on a project called Learning Energy System in Edinburgh University, and it's in collaboration with Edinburgh Council. And they're working with primary schools across Scotland to basically learn from school children and kids, and also giving them a way to understand the connection between energy, electricity, and learning. So we're getting them to program in Scratch. You can, for example, write a program that you're in a classroom, and if there is no character moving for a while, then it turns the light off. So then you can kind of get people to basically code those thinkings instead of like talking or asking them to do things. They can actually go and program in Scratch and learn them. So that's one example. I don't know, do you guys got any examples?
A little bit. I mean, I suppose there's two aspects to thinking about using code in the classroom. One is using it in order to teach coding, and then you have game design or robot battles or fun stuff like that as a hook to get to get kids coding. But then on the other hand, you can use code, and I think this is partly what your project is doing, using the code as a way of teaching something else. So I mean, I actually home educate my kid, and one of the things we've been working on, he's sometimes a little reluctant over math, so instead of going sort of straight into, we've been doing a little bit of linear algebra and multiplying matrices and such like, and the way we've been doing it is actually together writing code in Python that breaks it down into really, really tiny steps that are, some of them just a single line of code. And by breaking it down and simplifying it like that, I mean, so much of teaching and learning involves breaking a complex thing down into its smallest and most comprehensible constituents. And a lot of the art of writing code is precisely doing that. It's breaking things down into very small steps that even a stupid computer can understand.
And one more thing I was going to mention, I think one of you in the forums mentioned about developing, I think it was the Pong game, further, and you said introducing 2 players and playing with the computer. So that's kind of like brings in the like concepts like artificial intelligence, which is another computer science field that people like put their whole life on it, of like developing ways for computers to be able to act in ways that we do. But I think a starting point for getting more idea of that, first of all, is in your Scratch game to introduce those elements. And there's also another kind of similar to Scratch, but then you need to write codes instead of visual ways, called robocode. And you can download this platform. It's very easy to download. And what happens, you've got different tanks, and you program the code for it, for example, and they've got lots of procedures or functions. And you can say, is there any tank shooting at me? If there is, move left, move right, move forward, or kind of move randomly. So then you can start to learn about AI in those terms. And they also got like a tournament annually, as far as I remember, that you can upload your tank and see how it will function. So we did it. Cool, yeah, we did one tournament 2 weeks ago in somewhere in Edinburgh with some kids, and they developed their own algorithms and AI, and we put all these 10 tanks together, and then you can watch them. And it was really exciting. I put my tanks as well, but I lost. Anyway.
Going back to the how to use Scratch in the classroom, and how to learn how to code, how to use Scratch for other topics, other subjects. When it comes to the use of Scratch in the classroom, I highly recommend it to teachers. I know there's quite a lot of teachers following our course. First of all, thank you for being a part of this community. And I do think that Scratch works well in the classroom. Many schools in the United Kingdom do use Scratch and other platforms. There are lots of others out there. And when it comes to using our course, the Code Yourself material, feel free to use our material in the classroom. So there are different ways to do that. You could register along with your students and just follow the course, or you could just use the content. Pick some topics that you like, pick some examples that you like, some videos, and just use those. Feed them into your teaching. I know there's an interest out there, and would be very, very happy to see our ideas and our work being used in schools. So as long as you follow the license of the course, which is described in the Code Yourself page. Please feel free to use and build upon.
That's great.
Was there anything else in week 3 that you would like to talk about? Or?
There was also some people were wondering about if I don't know if you have an answer for it yet or not, but if the course is going to be running again, or when, or how is it going to be like?
That's a very good question. I'm afraid I don't have a concrete answer on that. So most probably will run again, but there's no concrete plans on when that's going to be. So instead of giving you a date that is probably going to be incorrect, I think I would recommend you to check your emails. So if you've already registered for this course, you should receive an email about the next session once this is decided, once this is scheduled. If you haven't registered, or if some of your friends have not registered for this course and they would like to find out about it, there's on Coursera, there's this option of adding a course to your watch list. Yeah. So if you add a course on the watch list, once the date is announced, you receive an email and you know about it, and then you can decide whether to register or not.
I think it will also, because the way that Coursera works, if you do that, then it will also encourage Coursera to try and start the course. So if you're actually interested in starting, that would be a good way of pushing it.
Yeah.
Because if they get enough people interested, and there's no reason why not to.
So spread the word.
And
shall we move to week 4? Anything interesting happening in the week 4 forums?
Well, a lot of what was in the week 4 forums was dominated by talking and thinking about the peer assessed project. So there was an awful lot of people asking for help with their project and receiving very good answers. See, I'm not going to go into too much detail here. I mean, the project is now done and in, but I will just say
in evaluation phase.
But it is really, really great to see everyone coming together and answering each other's questions. I mean, the way MOOCs work, the reason it is possible for a small team of people to run a course that teaches programming to thousands of people all around the world is that most of the teaching is done by other students, and that is awesome. So thank you, everyone. Also saved me an awful lot of work, and Sander, who is not today. So the other thing that was been discussed quite a bit on the forums in the last week is around procedures, and I wanted to go into this a bit. So there was one of the threads that already started on procedures in cooking. There's one quite nice answer to it that I just wanted to highlight by Stephen Spears. See, this was for making either homemade or shop-bought pizza. And the nice part is there's a sort of top-level procedure for whatever kind of pizza you have, putting it on a tray, putting it in the oven, taking it out at the appropriate time, and then cutting it up and enjoying it. But then you can plug into that sub-components, sub-procedure for what to do if you're making homemade pizza. You could have another one for going to the shops and buying a pizza, and then that. And the point is the top-level code then, the top-level procedure, is agnostic to what the lower-level procedures are. They don't need, the top-level procedure doesn't need to see what's going on at the lower level. And you could drill down a little further. So there's sub-procedure step in the homemade pizza procedure, add toppings. You could go into that in a little more detail, have a procedure for take a topping, is it already, have a conditional, is it already in small bite-sized chunks? If so, fine. If not, chop it up into pieces, then spread evenly over the top, and then you could say put that within an iteration context. You have a list of toppings. For each topping, apply this procedure, and so you can again break down a a multi-stage task into much, much smaller sort of bite-sized chunks. See, there was another one that I wanted to mention, the generalizing the square drawing procedures thread. There have been some really nice examples posted, particularly by Beatriz Trejo. I think that's pronounced right. Maybe, I don't know, maybe I'm not. Here, this was programs for doing simple but very attractive sort of geometric drawings in which procedures calling on other procedures, calling on other procedures. And this is, I mean, if you go to this thread and have a look inside the code, this is very, very nicely done.
Which thread is that? Is that the one that is pinned at the top of the...
Yes, that is generalizing the square drawing procedures further. And I mean, one of the nice things about procedures is that you can have a procedure calling another procedure, or have a procedure calling itself. This is, so I wanted to talk about this just briefly. This is a slightly more advanced topic, that of what we call recursion. So for instance, I was thinking about an example. This is actually one that is quite commonly used in sort of first-year computer science courses at university. So imagine you have a dictionary. This is a slightly unusual dictionary because it isn't bound. It's just a pile of pieces of paper, and there's only one definition per piece of paper. So if you come up with a procedure that says, take a pile of paper, if you're looking for some word, let's say sesquipedalian. This is a slightly obscuring.
Me too.
It actually means a word that is at least 6.5 feet long.
Oh.
So the procedure is take a stack of paper, check to see if the word you're looking for is on the top of that stack. You can embed this within another procedure that says, if it's not on the top of your stack, divide the stack in two. We assume here that all these papers are ordered like a dictionary. So divide it in two. You've already checked the top stack, check the bottom one. And from that, you can tell whether or not the word on the top stack is the word on the top of the bottom stack is in the top stack or the bottom. And you can then take the one that your word is going to be in and reapply that procedure. Check the top. If the top word is the word you want, good. If not, divide in two, and so on and so on. And this can be, this procedure can then call on itself to sort of cycle itself further and further down until you get the word you're after.
Yeah. That's probably like how you can calculate things like in mathematics, power of a number, or square root, or things like that. You can probably use recursion. And also, I think in real life, as you said, like if I'm looking for something and there are two boxes, so I look at these boxes half deeply, and then if it's not there, I look at the other one. If I don't find it, then I'll go deeper in this one. So it's kind of, yeah, I think it's.
And in the last Hangout, there was a question about languages, different programming languages, and I think I mentioned Prolog because it's the language I enjoy the most. And Prolog is recursive. So if you do like the idea of recursion and things calling themselves, feel free to have a look at Prolog. So anything else from week 4?
Just one other thing. So there was a post started in general discussion, titled "Computer Science Terms and Definitions." I think this is a great idea to have a dictionary of sort of the basic terms that can be referred back to. This was got going by one Sean Hamilton Cole, but the beginning of the glossary was started by Jason Kibb, who I think experiences more hours in the day than most people do. Thank you, Jason.
Thank you.
Been a massive help to everyone over the last few weeks. So I just wanted to draw attention to that, and no doubt more definitions will be added by other students.
But Dave, I have an idea for that glossary as well. Like, why not someone, I think, if they want, put that in Scratch, and then you can click on different things, and it will bring so it'll be a great addition to this course.
Sounds like a good idea. Yeah. And this way you could, this project could be there forever. I mean, it's not just specific to this course. You can just create the project and remix it and build on it.
Yeah, and other people then can it'll be like an online repository or dictionary of, and then maybe we can add some recursion as well.
Everyone's happy. Search for that word. What was it again?
Sesquipedalian.
You
can have a definition in the dictionary for recursion. See recursion. Which reminds me, just before we go, my favorite example of recursion is something that everyone should bear in mind when planning projects, and that is Hofstadter's law. Hofstadter's law states that it will always take longer than you think, even if you account for Hofstadter's law.
Okay, so multiply everything by 7, that's what I do.
No, because that's you just trying to take account of Hofstadter's law. It will take longer than that.
Should we look at the questions that's been...
Before we actually go to the live questions, I think it might be worth talking a little bit about evaluation and grading, because there's been quite a lot of questions in the forums about that. So first of all, how does the grading of the course work? You can find all the details in the course logistics page, but just very briefly, your assessment is based on the 5 quizzes, each of which count for 10 points. And then there's the 2 peer assessed projects. The first one counts for 20 points and the second one for 30 points. And what happens when this course finishes? What happens when you've submitted all your coursework, let's say? So about a week after all the coursework is submitted and evaluated, after everything is done, you should receive an email from Coursera which tells you that you can go and check your grades, and then after a few days you're probably going to be able to download your certificate. By the way, we might have mentioned it in the previous Hangout, I don't remember. It's definitely on your course syllabus page. If you get above 50% for this course, you get a statement of accomplishment. And if you get above 75% and above, you get a distinction. And we've been checking what is going on with your coursework so far, and we're very impressed. People are doing really well, so keep up the good work.
Can I ask one question myself?
Yes.
So imagine if I'm doing really well, like giving all the coursework, doing all the quizzes, and then in the last week I'm a bit kind of like missed on the deadlines, and then can I do a late submission, or?
I'm afraid not. So the deadlines that we've got specified in the course logistics page, they're fixed, and it's for fairness reasons. Yes. The good news is that the 5 quizzes, the deadline is on the 12th of April, if I'm not incorrect.
For which
the quizzes?
The quizzes is 12th of April.
12th of April. So if you start working on them now, then this means you've got more time later on this course to focus on the projects.
Yeah, just be careful, because then the project one is 8th of April. So you need to
the evaluation ends then. Yes. Yeah. So actually, currently we're going through the evaluation phase for the first project, and there's been many questions about the first project. So perhaps it's worth clarifying a few points now. So the first project was about creating an animation in Scratch and uploading it so that your classmates can evaluate it. There were reasons why we said we would like you to upload it. I know that several students found it hard or decided not to upload it, and they just posted a link. We would recommend not doing that for the second one, so we want to clarify this. And there's been quite a few questions in the forums about how to evaluate projects that have not been uploaded, where they have links, but the links are not working. So this complicates things a bit. So for the people that are currently evaluating projects, my advice is just look at the different questions in the marking scheme and focus on that. If there's no project for you to evaluate, that's it. I mean, each question would be, I suppose, 0. If you can't run the program, if you can't see the characters, if you can't hear the sounds, So be careful when you're submitting your projects. Make sure you follow the instructions very carefully. And there was, for instance, a question in the forum about how do I open a link to evaluate? So say someone has uploaded a Scratch file. How can we download it to view it? So you just click it, download it in your computer, and then you can open it either with a Scratch offline editor or by using Scratch Online. And I will not give you the details just now because Nova Jackson has given very precise, very clear instructions on how to do that. So if you go to the how do I open link to evaluate post, you'll see Nova's suggestions there. So her posts have been upvoted, and well done, because this is very helpful. So thanks.
Yeah, another post saving us time.
Yes. Right. I suppose we can move on to talk about some of the live questions we have from the Hangouts.
So one question. First of all, Beatrice said thank you, and thank you to you.
Thank you.
Yeah, thanks.
And Engel, I think she's asking, can we have a PHP course from University of Edinburgh? Alright, maybe you can explain how complicated and difficult developing courses are. And
it's a lot of work. It's a lot of fun. I'm not aware of any plans from the University of Edinburgh currently to create a PHP course, but there are several courses out there. So even if it's not a University of Edinburgh one, feel free to explore. Even if it's not on Coursera, feel free to explore. So really, our suggestion is for you to go find the resources that work for you best.
And I think part of the things that, like, while I was working on developing the course, part of the things that I felt is when you understand what the algorithm is, what procedures are, what functions are, then you're not bound into anything. You can just look on Wikipedia programming languages, look at the list, and after that, languages are basically just words, and then you can just use any language basically to program. It will take you some time to learn those kind of keywords, but then after that, you can just develop in anything. Yes. So even feel free to start searching on Google, basic PHP page, learn the keywords, make up your own one. When you get the building blocks, when you understand the grammar of all of these languages, then you can do anything you want.
Yeah, I saw recently sometimes follow threads on Quora, which is a question and answer website, and there was a question about what are the most important programming languages to learn if you want to go into software development or whatever, and about half of the answers were actually which languages are the least important part. Having the programming concepts means you can then, once you've got that, learning other languages is a relatively small task. Knowing having the ideas of how to code, how to break a task down, how to think of a problem in these sort of
computational way.
Yeah, exactly.
Yes.
Is a far bigger part. So if you pick this up, if you pick these skills up from this course, then you can take that into whatever programming language you like.
And this is really our goal, to inspire you, to get you thinking computationally about problems, and to equip you with the fundamentals to move on to different languages. And I do agree with the point you made about, knowing one language means you can easily learn another one, and that the fact that, the specific syntax or keywords do not matter. It's about the way of thinking.
Yeah.
And so if you've been watching the interviews that we've had in this course, I remember Rosa in her interview in week 1, she did mention that. And I remember she said, the keywords and the syntax is the last thing to care about. I totally agree. And next week, we have an interview with a first-year student in our school who actually raised the same point. He said, yeah, I know I can program in C, in Python, in Haskell, but actually once you learn your first language, it's much easier to learn the rest.
Mm-hmm.
So if you feel good about your Scratch programming skills, I think this gives you plenty of confidence to move on to more languages to explore.
And there's also a follow-on question about the PHP summits that I want to learn about web development. There is one. So basically, first of all, the whole internet is web development. So when you're browsing, when you're looking at things, just think about these web pages. Think about how they're designed and the different parts. And a good resource also is W3 Schools. So they've got lots of tutorials. And then when you don't find things in here, which I'm sure you will, then the next step is to just put it on DuckDuckGo or Google, just what you want to learn. I want to do a homepage, and then there's lots of tutorials made by people like you guys helping each other. So I think first step is just to actually define yourself a project and then start doing it.
Most definitely.
You might not even need any kind of learning as much.
Then there's another question coming that came up just a few minutes ago from the Hangout forum. Can we code if we're not good at maths? What do you think, Dave?
I think that learning to code will actually help you be better at maths, for one thing. As a part of learning maths is, again, any piece of complicated maths is just lots of different pieces of much simpler maths put together. This is the same skill that you acquire through learning to program. If you come into it without having that skill in the mathematical domain, that's fine. You will learn it as you learn to code, and then may find that once you've got that in the coding domain, you might even feel a bit more confident about mathematics. The other thing is, so one of the courses I'm involved in teaching here in Edinburgh is a course on cognitive science. So we do some, and part of it involves doing some basic sort of AI programming inside MATLAB, which is another programming language that's sort of specialized for doing these sorts of cognitive science and more sort of mathematical applications within science rather than coding programs. And about half of the students that we get on this course come from the School of Informatics, and half of them come from the School of Philosophy, Psychology, and Language Sciences. And it is always a little bit of a shock to them, having spent several years thinking of themselves as more sort of art students type, sort of more into the fluffier side of academia. And then the first thing they get is a bunch of linear algebra and MATLAB coding. But once they're given sort of the basic skills of thinking in conditionals and loops, that's enough to start putting together simple pieces of code that come together to make more sophisticated pieces of code. One thing else sometimes shock my the databases and analysis students with is the fact that some of what they do is going to be mathematical, but when you're designing a piece of code, some of it is actually making design decisions, and suddenly computer science starts to look a lot like an arts discipline.
Yeah, there's also, like, I was going to use an example of, if you think about a puzzle, someone else did all the drawing and then broke it into little pieces of puzzle, and then you sit down and put those pieces of puzzle together and you make a drawing. but you're not necessarily good at drawing. So I sometimes think in this way, like I find myself sometimes struggling, I don't know, programming and image processing or a math formula, and then I just search on the internet how to draw a circle, for example, and then someone else made a function or a code that will already doing it, and it's available for grab and for free. So I copy that and then I use that. So it's kind of also learning. It's basically about having confidence, believing in yourself, and just look, and then you find pieces of puzzle made by everybody else. Because the problem that you face, there's 7 billion people, more than 7 billion people in the world, 9 billion actually. But they are faced. Some of them are like, lots of them are programming, finding problems, finding solutions, and then they share it on the internet, like what you've been doing in Discord. So then you kind of put this puzzle together. So you don't also necessarily need to be good at all those different parts of programming. So
I agree. I mean, a short answer, no, you don't need to be an expert in maths. You don't even need to like maths. I do agree with Dave. Maybe just by playing around with Scratch and any other language, you might turn to like it. But how about you guys? Do you like maths? Do you like maths, Hedy?
I used to do more mathematics, but now I don't really think about mathematics as much. Yeah. So,
How about you, Dave?
I don't like them much, I think.
I think maths is awesome. I love maths. I'm coming to this. So my first degree was English literature. I sort of got interested in the language, and from there got into linguistics, and from there got into theories in linguistics that could only be modeled by writing code to simulate the theory, and therefore ended up having to go through that process myself of going from fluffy, happy arts and humanities person to learning the crunchy sort of mathematics and code side. So I've had very little actual formal mathematical education, but I've learned a lot just off of Wikipedia and off of looking at code. You know, how is this solved? Oh, I see. This is why that works. So yes, it's fun. I like it. It's the short version of the answer.
Right. There's I think one final question from Beatrice. She's asking, can you talk about requirements for projects? I want to start working on it. So gathering your requirements, we've talked a little bit about this in this course. We've said that it's very important. It's important to think what it is that you want to program before you go ahead and build your program, before you design it even. Even though I'm tempted to give you some ideas for projects, I think I won't do it. And I won't give you a list of requirements. I'm going to ask the rest of the community to share your ideas for new projects, even wacky ideas that you don't know whether they're going to work, but you just think they're cool ideas. Share them in the general discussion forum, and just inspire each other, prompt each other, and enrich each other's ideas. And you could also ask friends, family members, classmates, just to hear what other people think. So without, they don't need to know about programming, just what they would like to play if it's a game. This sort of thing.
Great idea.
So I think this is us with the questions from the live forum. We don't have much time left. I remember there's been a very good discussion in the forums about where to go next and what other languages to learn. We've talked about this last time, so I would again refer you to that thread in the forum. But just to let you know that in week 5, so the material that is released in a few days, we're going to be showing you links between a program in Scratch and a program in Python, just to inspire you and to show you that it can be done.
And I wanted to thank also Maria back there writing your question big on a whiteboard behind, and so we can all easily read it. And yeah, keep telling us.
I forgot to say that Ines, who is currently in Uruguay, is saying hello to everyone. Good. So that's us.
So.
Good to share this time with you and share this experience with you.
Thanks, everyone.
Yeah, have a nice weekend.
See you soon. Bye.
And keep coding.